Bismillahirrahmanirrahim. Good afternoon, everybody. If you are in Egypt, and good morning if you are in the States. And on behalf of the Essential Education Group, I'd like to welcome you in the first Respiratory Critical Care series. So today we are going to talk about a very nice topic. My name is Mohammed Amin. I'm an assistant professor, Critical Care Medicine, Cairo University. Today we are going to talk about a very interesting topic, which is dual control modes in mechanical ventilation. Most of us know about volume control mode and pressure control mode. Yet, some of us has practiced what's so-called dual control modes. I would like to start my lecture with this nice question, this strange yet very important question. Are these dual control modes really dual? Do they follow the taxonomy or the classification of dual control modes? Actually, surprisingly, the answer to this question is no. I don't prefer to call them dual control modes. So we would change the topic of the lecture, or the title of the lecture, to adaptive control modes. Let's start our lecture. This is our Qasr Al-Aini School of Medicine. I would like to start by expressing my gratitude to my professors in critical care department for their continuous support and encouragement, especially my mentor and professor, Dr. Sharif Mukhtar. So before starting in our topic today, I just have one advice to my dear colleagues, respiratory therapists, doctor, physician, ICU critical care. Before dealing with your mechanical ventilation, just get some relationship with it and be familiar with your device. Whatever your device, generic or commercial type, they look alike in many features, but they have some changes and some differences in other features. So first of all, you should be familiar with your device. The objectives of our session today, first, is an introduction to the mechanical ventilation modes. We will understand what is a ventilator mode is and the definition of the mode. This is very essential to know what is a mechanical ventilation mode is. What is the definition of mechanical ventilation mode, and what do we refer to mechanical ventilation mode? We have many modes of mechanical ventilation. Some of them are conventional modes used commonly by us, and some of them are called non-traditional or non-conventional modes, are not usually used by us. After the evolution and invention of many modes, nowadays we have something like 175 modes available on 39 or 40 generic ventilators. So knowing all of them is something very difficult. So it became very essential to know the classification and the taxonomy of mechanical ventilation modes. How do we classify the modes? How do we cluster them? What modes are like each other, and what modes do not look like each other? So the taxonomy and classification of mechanical ventilation modes has become an essential part of the training of the respiratory therapy, the intensive care doctor, and the pulmonary physician. Last, we will talk about the categorization of the non-traditional modes. We all use the conventional modes: volume control mode, pressure control mode, SIMV, and the spontaneous mode. These four modes have been established in our practice since 1980s. Yet, since the 1990s till date, there have been many modes in the market. So we are going to categorize them in clusters that looks like each other. That's the first objective of our session, is an introduction to the mechanical ventilation mode. Second objective is to talk specifically about what so-called dual control modes. And as we said before, we don't prefer to call them dual control modes, and we will know why after the session. I do prefer to call them adaptive control modes rather than dual control modes. We'll know the description and the principle of operation of these modes. How do they work? What's meant by dual control? Why did they call it dual control? And why do I call them adaptive control mode? And how do they operate and regulate the process of ventilation? Secondly, we'll know the different classification of these modes. We have two different types of adaptive modes. And then we will know the advantages and disadvantages of each mode. And at last, the last objective of this session is to know examples of common adaptive control modes and how do we use them and set them in the real life practice. Like the volume support mode, we commonly see it in many ventilators. Pressure regulated volume control, or what's so-called PRVC mode, We sometimes see it in some ventilators. And the AutoFlow mode or the AutoFlow feature, which is specific feature for the trigger ventilator. Okay. So let's start our journey with an introduction to mechanical ventilation mode. Okay. Starting our journey, we just have to review some basic principles about the basic variables during a mechanical breath. Let's remind each other with the mechanical breath. There are 4 variables in any mechanical breath that usually affect each other. The first variable is the pressure difference, which is the force that pushes the air inside the lung. And the volume change, which is the amount of air enters the lung. The gas flow, which is the speed. Flow is not synonym to speed, but it's look alike a little bit. And the time that takes the air to enter the lung and to exit the lung. These are the 4 variables. And we all know that these 4 variables affect each other in many ways. Okay. In a ventilator mode, you can usually control and set only 2 variables. So you either set the volume, tidal volume, and the flow, or you set the pressure and the time. Okay. As we know that the compliance of the lung, which is equal to the delta volume, or compliance of the respiratory system equals the delta volume over the delta pressure. So if we control the pressure, we cannot control the volume at the same time for a given lung compliance. When we control the volume, we cannot control the pressure at the same time. So dual controlling of both the volume and pressure from the physical point of view is impossible. And a control volume only, so the pressure differs from a lung to another according to its compliance, or I control the pressure or the force and the volume that this pressure pushes is different from lung to another according to its compliance. So basically, dual controlling seems like an impossible mission. So how we are going to do with this? Okay. Second basic feature we want to review is the phases of mechanical breath. We all know that the mechanical breath consists of 4 phases. The trigger of inspiration, start of inspiration, followed by the flow of gas till the limit of inspiration, then cycle of inspiration, and the end of inspiration, then it comes the expiration itself. As we remember from the basic ventilation training we all had, we do have 4 types of mechanical breath. Controlled breath, which is either volume controlled or pressure controlled. The machine trigger and limit and cycle this breath. Assisted breath, which is either a volume assist or a pressure assist, where the patient trigger the breath and the ventilator limit and cycle the breath. We have a supported breath and spontaneous breath. For the sake of classification and medical literature, the controlled and assisted breaths are called mandatory breaths. So any breath that the ventilator cycles it and controls its time is called mandatory breath. And any breath that the patient starts it and ends it is called spontaneous breath. So when we call a spontaneous breath, we refer to a breath that is initiated and ended by the patient. Either it is supported or completely spontaneous. So the first 2 breaths are called mandatory breaths, the controlled and the assisted, and the second 2 breaths are called spontaneous breaths, either supported or spontaneous. This is very important when coming to the classification and to reading the literature about ventilation, because when we refer to a spontaneous breath in the literature, we mean supported and spontaneous, not only spontaneous. Okay, so let's start. What is the definition of mechanical ventilation mode? What is a mode of mechanical ventilation? We have many modes. We can select out of them. Hundreds of modes, as we said, 170, I think. If we get the mimics with each other, we have something like 89 or 80 or 90 mechanical ventilation mode. So what is the definition of the mode? What is a mode? Actually, the mode can be defined from my point of view as a software on the computer of the ventilator that determines the pattern of the patient-ventilator interaction. There is an interaction between the ventilator and the patient. Every mode determines this pattern of interaction. Some modes allow interaction, some modes does not allow any interaction. It also determines the type of breath delivered to the patient. Okay, so the mode is the program or the software that determines the pattern of interaction and determines the types of breaths that the patient can take from this mode. Another accepted definition is The mode is the process which the mechanical ventilator determines when and which type of mechanical breath should be provided to the patient. Okay, so it determines the timing of the mechanical breath and which type to give each patient according to his request or absence of request. So defining a mode consists of three basic components. First, the ventilator breath control variable. What is the control variable of this mode? Do we control the volume or we control the pressure? Secondly, the breath sequence. What types of breath that this mode can give? Does it give spontaneous breath or mandatory breath or both? And the targeting scheme. And this is a very essential issue we will going to discuss now. So the classification of mechanical ventilation mode or the taxonomy of mechanical ventilation modes is composed of three components. The first is the ventilator control variable. What is the control variable? It is the variable which is independent of the patient lung mechanics. So this is the variable that the doctor or the RT sets in the ventilation, and it's not affected by any change of the lung mechanics. We have two control variables, two options of control variables. Either volume control, and in volume control mode, we set both volume and flow. So volume control mode, when we refer to the control variable, refers to controlling both volume and flow. مش بس الvolume, we control volume and flow. Pressure control modes refers to controlling the pressure, so the volume is variable. And this is very essential in our topic today, dual control. How we are going to control the volume and pressure. We are going to know this later on. So this is the first component of classification of any mode, the control variable. Is it volume or pressure? The second component is the breath sequence. We have three options or three variants of breath sequence. Either a mode giving all breaths mandatory or assisted. We just said that the controlled and mandatory and assisted breaths are considered as mandatory. So any mode giving mandatory breaths when the patient does not trigger and assisted breaths when the patient triggers is called in the taxonomy continuous mandatory ventilation, CMV. This is not the CMV mode in the Hamilton or the old Evita 2 ventilators. This is part of the taxonomy of the modes. So any mode who gives only mandatory breath or assisted breath is called CMV or continuous mandatory ventilation. And any mode who gives only spontaneous or supported breaths is called continuous spontaneous ventilation. So we have a CMV and the CSV. And some modes can give mandatory breaths, and in between, they give some supported or spontaneous breaths, like the SIMV. So the breath sequence here is intermittent mandatory ventilation. So we have three breath sequence, CMV, IMV, and CSV. The last component of taxonomy of modes is called the targeting scheme. The targeting scheme is the relationship between the operator input, the settings that the RT or the doctor set on the ventilator, and the output that happens on the ventilator. And we have 7 targeting schemes or 7 models the ventilator can deal and change the input of the doctor so we get an output in the patient. The first one, which is the most common one used by us, is the set point. What is a set point targeting scheme or operating model for a ventilator? It's just that the operator, the doctor or the RT, set all the parameters of the waveform. He sets the volume directly and the flow directly by numbers, and that's the volume and flow that comes out. Or he sets the pressure and the inspiratory time in pressure control mode, and that the pressure is performed by the ventilation without any change. But we have another targeting scheme that is related to our topic today, which is called adaptive targeting scheme. What is adaptive targeting scheme? Adaptive targeting scheme, that the variable, limit variable, which is the pressure, is automatically, without any change from the doctor, is adjusted over several breaths to maintain the target volume. So there is a pressure limit, we have a pressure limit, and this pressure limit is not fixed. It increases or decrease according to the lung compliance and changes in resistance in the patient condition. So it adapts itself to what happens inside the patient. And this is most of the dual control modes that we refer to as dual control are actually non-dual control. They are adaptive control. Okay. We have other targeting scheme like the servo targeting scheme. Servo is something like amplification of the patient effort, like the NAVA and PAV. So NAVA and PAV just work like the power steering of the car. When you just have a car with a power steering, when you just get to the left, a little left, the wheels of the car just give too much left deviation. So this is what the NAVA and the PAV do. When the patient make a little effort in the PAV, the ventilator maximize its effort. In the NAVA, when the patient intends او ينوي ان هو يعمل a little effort, the ventilator maximize its intention, and so on. So we have 7 targeting scheme that we use in a ventilator mode. So any mode, to classify the mode, we should know the ventilator control variable and the breath sequence and the targeting scheme, and that's how we know what mode we are dealing with. So what are our conventional modes that we usually use in the mechanical ventilation? We have 4 conventional modes we are all accustomed to. The volume control mode, ACVC, whatever its name. When the patient does not trigger, it gives the patient a controlled breath. When the patient tries to trigger, he gets an assisted breath. So the ACV or the ACVC or the volume control mode only gives mandatory breath, either controlled or assisted. We just mentioned that the assisted in the literature is considered a mandatory. The pressure control mode, which is similar to the volume control mode, when the patient does not trigger, it gives him a controlled breath. But when the patient triggers a breath, it gives him an assisted breath. So the PCV or the pressure control ventilation mode gives only mandatory breaths. What about the SIMV? SIMV mode gives a controlled breath when the patient does not trigger, and gives an assisted breath if the patient trigger in the synchronization period for the controlled breath. And in between, العيان يقدر ياخد either spontaneous or supported breath. So it gives mandatory and gives spontaneous breath. What about the spontaneous mode? Spontaneous mode, CPAP or pressure support, CPAP plus pressure support, either gives spontaneous breath when you do not apply a pressure support, or gives you a supported breath when you apply a pressure support. So according to the taxonomy, the ACV mode or the volume control mode we are accustomed to is called a volume control because you control the flow and the volume. It's a CMV mode because it gives you only controlled or assisted breath, and it's a set point targeting scheme because you control by number the peak inspiratory flow rate and the tidal volume. So they are set by number. So they are not adaptive, not optimal, do not follow intelligent mode. So they are just set points. So this is the classification of the ACV. The PCV mode, the regular PCV mode, is called the pressure control because you control the pressure inspiratory. CMV because it gives only controlled or assisted breath. Set point also in most types. Set point because you set the pressure and the time of inspiration and the rise time by number on the ventilator. While the SIMV, the usual SIMV in most ventilators is usually a volume control because you set the volume and the flow in the controlled and the assisted breath. IMV because it gives controlled and assisted on the time of control, and it can give spontaneous and supported breaths in between. So it's intermittent mandatory ventilation. It's usually a set point and sometimes called a dual control because it varies between pressure and volume control. But this is not the dual control we are dealing with in the topic of the ventilation. Okay. At last, the spontaneous mode, the pressure support or the CPAP, is a pressure control because you limit and control the pressure support. CSV, continuous spontaneous ventilation because it only gives supported or spontaneous ventilation. And set point because you set the number of the pressure support directly on the ventilator. So these are the classification or the taxonomy of conventional modes we usually use in our ventilation. Let's talk about the non-conventional mode. Let's talk first how do we classify the pressure support mode as an example. So pressure support mode, when dealing with a ventilator control variable in pressure support, what do we control? Volume or pressure? Okay, that's right, pressure. So the pressure is the limit. All the breaths are pressure limited. So the control variable is pressure control in the pressure support mode. What about the breath sequence? Do the pressure support ventilation mode can give any mandatory breath? No. So it's a continuous, spontaneous ventilation. What about the targeting scheme? As we said, it's a set point. We set the pressure support and the expiratory trigger sensitivity and the rest time. So we have a set point for the limit and the control variable. That's how we classify a pressure support ventilation mode. Okay. Now, as we finished our introduction to the conventional modes, we shall go to the categorization of the non-conventional modes. We do have 4 or 5 conventional modes commonly used in our ventilators, but we do have something like 160 modes that we do not commonly use in our ventilation. So we have to cluster them in order to understand each group. How does it work? Actually, we do have some clustering of our own or a categorization of our own to the non-conventional or non-traditional mechanical ventilation modes. We have high frequency modes. These are modes that give breaths more than 150 breaths per minute, like the high frequency oscillatory ventilation and the high frequency jet ventilation. This is not our topic today. We have a bi-level modes giving 2 levels of CPAP, allowing spontaneous breath on each level, like the BiPAP mode and the APRV mode. They look the same. They are exactly the same, and they are exactly opposite to each other. And we have our dual control modes, like the PRVC, the volume support, and the AutoFlow. And this is our topic today. We have proportional modes, our servo control modes, our patient control modes, like the PAV and NAVA. We will talk about them the next month. And we have intelligent modes like the IntelliVent and the Smart Care modes, and others. So let's talk about one of our modes today, the volume support mode. Okay. What do we need to know about any mode? I call this mode card, a card of introduction to the mode. Any mode, any mode, conventional or non-conventional, there are 9 information we need to understand about this mode. First, the terminology of the mode in different generics of commercially available ventilators. Sometimes the mode that you use is called another name and another nomenclature because there is no standardized nomenclature for the modes of ventilation. So the volume control mode, sometimes it's called IPPV mode or VCV mode or CMV mode. So the different nomenclature should be understood by each of us. Secondly, we should know the taxonomy of the modes. We have already discussed the taxonomy of modes. Third, types of breath delivered by the mode and the breath sequence. Settings that we usually set in this mode, and how do we set them? ازاي نظبط المود دوت. Troubleshooting of the mode. When we have hypoxia in this mode, how we are going to manage hypoxia using our settings. Or when we have hypercarbia, how in this exact mode we are going to watch the CO2. Advantages and disadvantages of the mode, and graph interpretation of this mode to understand the normal graphics and waveforms and scalars and loops in each mode. So let's start our journey with the dual control modes, or preferably called adaptive control modes. So dual control modes are not dual control modes. They are a variant of pressure control modes. Dual control modes are a subtype or subgroup of pressure control modes, actually. These modes deliver a constant pressure through the whole inspiratory cycle. The pressure is limited, as we can see. But this limit of pressure is not constant between breaths to each other. الليميت بتاع البريشر بتاعنا هنا في الدول كنترول مودز can increase or decrease according to the lung mechanics. The breaths are still pressure limited or pressure controlled, but this pressure limit or pressure control is not constant. It changes from one breath to another to adapt to the change of the compliance or resistance in the patient. These dual control modes, as any pressure control modes, use a descending flow waveform. Usually in the dual control mode and the pressure control mode, you do not control the flow. And this is an advantage of this mode. You let the patient, when he have his spontaneous effort in association with the ventilator, to choose his own flow, and he have usually a descending flow waveform. We have a target volume, which is set by the operator, as we can see in the dual control mode or the adaptive mode. When the target volume is not met, when the pressure limit does not achieve the target volume, the next breath, the pressure limit rises to achieve the tidal volume. So the tidal volume is achieved with the least pressure that can be done with the ventilator. This is an advantage of dual control modes. So dual control mode are pressure limited modes, but this pressure limited is not fixed. It increase or decrease to guarantee a tidal volume set by the operator of the ventilator. This is using a feedback mechanism through the algorithm of the ventilator. This is how dual control modes work. يبقى dual control modes عبارة عن pressure control modes, but their pressure limit is not fixed. It increase or decrease according to the lung compliance to achieve the tidal volume, the target tidal volume set by the operator. Okay. So what's the difference between the dual control mode, like the AutoFlow in the left and the right side, and the pressure control mode, the regular pressure control mode, like the one we see on the left side? Well, the pressure control mode, the pressure limit is fixed, whatever the compliance of the lung. So the tidal volume is not guaranteed. In any pressure control mode, there is no guarantee that the tidal volume will be achieved. But in the dual control mode, there is a pressure limit, but this pressure limit increase or decrease to achieve the tidal volume. So the tidal volume is guaranteed. So the difference between pressure control mode is the target tidal volume is being set up in the dual control mode, like the AutoFlow, the volume support, the PRVC, but there is no setting up tidal volume in any PV mode or any pressure control mode rather than the adaptive or dual control. They both use descending flow pattern, and this is more synchronous for the patient. They allow the patient to choose his flow, inspiratory flow. So this achieves more synchrony. So they look alike a little bit with some difference. But what about the difference between volume control mode and dual control mode? There is a big difference between volume control mode and dual control mode. The only similarity is that both of them guarantee the tidal volume that the operator, the respiratory therapy, the doctor adjust on the ventilator. But in the volume control mode, there is no fixed pressure during the inspiratory cycle. There are 3 levels of pressure: peak pressure, plateau pressure, and the PEEP. Yet in the dual control mode, like the AutoFlow or the PRVC, we do have a fixed pressure during the whole inspiratory cycle. Usually, volume control modes uses a constant flow pattern. A constant flow pattern, as we see on the left side. This is it. But dual control mode, being subtype of the pressure control mode, use a descending flow pattern, which is more synchronous for the patient, which allow more synchrony between the patient and the ventilator. Every volume control mode, the doctor sets up the tidal volume and the flow, the peak inspiratory flow rate. It's not called the volume control mode if you do not set the flow. But in the dual control mode or the AutoFlow and what else, you do not set a peak inspiratory flow rate. Instead, you just set the rise time, which is an indirect control of the flow. So what is the advantages of dual control modes? Dual control modes, that's why it's called adaptive. It adapts to patient change in compliance. When the compliance change, the pressure rise to achieve the tidal volume that needed. Okay. Tidal volume does not vary too much. Very minimal variation between breaths in the dual control mode. But in pressure control mode, once the patient have a problem in the resistance or in the compliance, the tidal volume will be variable, and the minute volume might not be achieved. Inspiratory flow is not limited like volume control modes. You leave the patient choose his own inspiratory flow pattern. It's a decelerating flow pattern, but the patient choose his flow rate by himself. So if the patient can trigger and has high inspiratory flow demands, so it would be more synchronous to give him a dual control mode rather than the volume control mode. So actually it gets advantages from the pressure control modes and gets some advantages from the volume control modes. That's why they refer to it as a dual control, although not being dual. But there are some disadvantages of the dual control modes, like the variation in the mean airway pressure. If the patient have too much variation in his lung compliance, there will be variation in the mean airway pressure. Also, when the patient demand is too much increased, okay, the ventilator will reduce the inspiratory pressure. He will be deceived. He will reduce the inspiratory pressure, thinking that the patient has an improving in the compliance, and that's what didn't happen. So increasing the patient work of breathing and making more discomfort. So sometimes it's deceiving. So AutoFlow usually or PRVC results in more patient ventilator synchrony, but in patients with high efforts, sometimes there are some discomfort and some distress. Before ending up, we have two types of dual control modes. There is a dual control mode that does not allow any breath without achieving the tidal volume. It's called dual control mode within a breath. So in the middle of the breath, it measures the tidal volume. If the tidal volume is okay, it keeps the, according to the set tidal volume, it keeps the pressure limit as it is. If the tidal volume is not okay, it shifts from a volume control, from a pressure limited breath to a flow control breath and gives the amount of tidal volume needed by the patient. The most common use type is VAPS, or volume assured pressure support. Actually, we don't have bird ventilators in Egypt, so we don't use VAPS anymore. It was available in the 2005 and 2004, but I don't think they are available commercially in Egypt nowadays. Neither bird nor bear. But other dual control modes does not calculate the compliance in the same breath. It just gives the pressure limit, let's say pressure limit of 20 and tidal volume needed 500 ml. If the pressure limit 20 does not achieve the 500 ml, the next breath, the pressure limit will rise by 3 centimeter water to achieve the target tidal volume. The common commercially available modes of the breath-to-breath dual control modes are the PRVC, found in Mackay, it was called Siemens in the past. AutoFlow feature, I'd rather prefer to call it feature, not a mode, in the dragger, specific to the dragger. Adaptive pressure ventilation, or the APV CMV in Hamilton, and volume control plus in the Bennett. You do have sometimes in Bennett ventilator volume control, VCV, and VCV plus. So VCV plus is a dual control mode, not a volume control mode. A spontaneous mode, which is dual control, common spontaneous mode, is the volume support mode. It's found in Siemens, Dragger, and in Bennett 980. Okay. So let's end our journey with dual control modes with giving some examples of commercially available dual control, or as we now call them, adaptive control modes, and know how we will set them on the ventilator. So the first mode, dual control mode we usually face in the ventilator, is the volume support mode, VS. It's called spontaneous CPAP VS in the Dragger, and it's called VS in the Bennett and the Mackay ventilators, getting Mackay ventilators. So sometimes they call it dynamic pressure support, okay, but the usual common name is volume support mode. So volume support mode, the control variable or the limit variable for every breath is pressure. It's pressure support. It gives only supported breath. So the control variable is pressure and its pressure limit. The breath sequence by the volume support mode, it's a pressure, it's a variation, it's a dynamic pressure support mode. So it only gives supported breath. So according to breath sequence, it's considered a continuous spontaneous ventilation, CSV. According to the targeting scheme, it's not dual control. It's an adaptive control because it adapts the pressure limits according to the pressure limit according to the patient compliance and resistance. So it changes its pressure limits up and down according to the patient compliance. So this is the volume support mode. It's pressure control, CSV, A, or adaptive targeting scheme. This is the taxonomy of the mode. Types of breaths delivered by the volume support mode are only supported breaths triggered by the patient and pressure limited, yet this pressure limit is not fixed. It changes up and down to achieve the tidal volume you need. Cycling is flow cycled like any supported breath. What do we set in the volume support mode? The target tidal volume. We don't set a fixed pressure support. We set a target tidal volume, 6 ml per kg from the predicted body weight as any pressure support. As we set any tidal volume. But this pressure support will vary to achieve this tidal volume. FI2, usually we start with a low FI2 because volume support is not used in a patient with a high requirements of FI2. So we use something like 0.4 to 0.6 FI2, 40 to 60% of oxygen. Sensitivity, not all generics of ventilators sensitivity is adjusted in the volume support mode, but if you need to adjust them, we will adjust them from 1 to 3 liters per minute if it's a flow sensitive ventilator. PEEP, as any ventilator, we adjust pressure support mode, we adjust the PEEP 3 to 5 centimeter water or according to the patient condition. The rise time will be adjusted according to the pressure time scale. So these are the settings usually adjusted by the volume support mode, FI2, tidal volume, PEEP, and slope or rise time. Notice here that it's very essential to adjust the alarm limit of the P high. In any dual control mode, the alarm is a part of the settings, not a part of the alarm. Because if you adjust the alarm settings to 25 centimeter water, if the pressure limit needed to achieve the tidal volume is more than 25 centimeter water, the ventilator will tell you, sorry, I cannot achieve this volume by the safety of the pressure. So here, setting the alarm is something like setting the maximum pressure support allowed during this mode. So setting the alarm is very essential. The high alarm is very essential in the volume support mode. Volume support mode differs a little bit from the volume assured pressure support mode. As we said, that volume support mode changes the pressure limit from breath to another. But in the volume assured pressure support, in the same breath, it changes the mode of the breath. What about the PRVC and the AutoFlow at the end? PRVC, or pressure regulated volume control, is a pressure controlled mode, yet it can give mandatory and assisted breath. That's the difference between them and the volume support mode. So if the patient is passive or not highly active, you can use the PRVC or the AutoFlow mode. Other modes, dual control modes that are CMV, are the adaptive pressure ventilation in Hamilton, and some of the SIMV modes can be switched by the AutoFlow feature into a dual control mode. Beside the volume control plus in the Bennett, as we just mentioned. So the PRVC is also a pressure control, yet the breath sequence here is not like the volume support, it's continuous mandatory ventilation. It allows the patient to have assisted or supported breath. That's a very good question, Dr. Ahmed Faid. We are going to discuss the difference between PRVC and AutoFlow now. Okay. It uses an adaptive targeting scheme. This is the PRVC. So PRVC is a specific mode found in servo I and servo U getting ventilators and found in some Care Fusion or GE ventilation. But the AutoFlow is not a mode. AutoFlow is rather a feature found in the only on the ventilator of dragger that shifts any volume mode into an adaptive mode. So when you have a volume control in dragger and just get to the auto flow button on, you just shift the volume control into a pressure limited with volume target. But you can use the auto flow in SIMV and you can use it in volume control. So any volume breath in the dragger ventilator is shifted to an adaptive breath using the auto flow feature. Okay, so, but PRVC is a specific mode which is only CMV. It gives only assisted or controlled breath. Okay, so there is no big difference actually. Yet they do the same function, but PRVC is a specific mode like we see here in the Mackay Servo I ventilator, while the auto flow is just a feature. You can set it on the ventilator of the dragger when you are dealing with the regular ACV mode or the SIMV volume control. So that's about both of them. You do not control the fluid. PRVC is found in the Mindray ventilation. I think PRVC is found in the Mindray ventilation, but I don't know what's its generic name. So now we finished our talk about the dual control modes or the adaptive control modes, and we are waiting for your questions. Thank you very much.
Many thanks, our Prof. Mohammed Amin. We have some questions from the audience. The first one was asking about the targeting scheme concept again. Please rediscuss the targeting scheme of the modes, my Prof. Mohammed.
This is a very good question. The targeting scheme of the mode is the relationship between what the operator has input or set on the ventilator and what actually is the output of the ventilator. So there are many different patterns when the doctor or the respiratory therapist sets something on the ventilator. It's not always what comes out from the ventilation. There are seven available targeting scheme of the ventilation. The most common used one is the set point. The set point is when you set pressure 20, you get an output of a pressure 20. There is no change in between the input and the output. This is the common traditional conventional ventilator mode. But the adaptive mode, the limit or the control variable here is the pressure. But this pressure is not fixed. You set a target volume and you don't set a flow. So this is not a volume control mode. You set a volume of 500 without setting any flow. And the pressure control adapts itself to reach the tidal volume you have set. So this is another model of what the ventilator do with you. What about the servo mode? The servo operating scheme or the servo targeting scheme? Sometimes like the NAVA, you set a NAVA 1. What do you mean by NAVA 1 in NAVA mode in getting ventilators? That for every 1 microvolt of electricity going to the diaphragm, you give 1 centimeter of pressure support. But when you give NAVA 2, you are multiplying the microvolts by 2. When you get NAVA 3, you are multiplying the microvolts by 3 to pressure support. So this is called servo, something like the power steering of the car. And there is an intelligent targeting scheme that use artificial intelligence like the IntelliVent mode, or there is sometimes something called biological targeting scheme, like the new mode that the Draeger has invented in the V600 and V800. You usually in the spontaneous breathing, you don't do the same effort every time consistently. Sometimes you do some variation or some random variation in your effort. So biologically, there is a random variation between every breath and each other. So Draeger has mimicked this in a new mode, giving a random pressure support, not targeting any tidal volume, not targeting any electricity of the diaphragm, just randomly following the random pattern in the usual patient. I hope I've answered your question regarding the targeting scheme or the pattern that which the ventilator output follow the input the doctor have been set. Okay.
Many thanks, Dr. Amin. There was another question by Dr. Ahmed Faid. He was asking about the difference between PRVC mode and AutoFlow, and I think that you have answered that the difference that AutoFlow is the application of this mode in the one ventilator, which is dragger ventilators, which is called which make a knock or a top in the mode inside the volume control mode to shift it to PRVC mode.
Yes.
Another question by Dr. Samsung. He was asking about another question outside the topic, which is the SIMV mode. What is the synchronization period or time? What is it time?
That's a very good question. I think Samsung is mobile, but Dr. Samsung or the doctor with the Samsung mobile, SIMV modes are not the same in every ventilator. So this question does not have a fixed answer for every generic commercial ventilator. The synchronization period is not the same between Hamilton, between Draeger. So refer to your manual of the ventilation. Actually, even the target scheme of the SIMV is not the same. Some SIMVs have a set point targeting scheme, and some of them have a dual control, not adaptive, dual control targeting scheme. So SIMV is a universal name, yet it have many prototypes under it. They are not the same. Even in the control variable, most SIMV are volume control, but we do have some SIMV as a pressure control. So this question does not apply to all of the SIMV modes in every generic. So just tell me which generic commercially you use in your ICU, and I'll tell you the answer of your question.
We have another question from Dr. Basma. Very important question about what is the most disadvantage of PRVC clinically.
Well, let's talk first about the advantage. We overestimated the advantages of PRVC actually, because the lung mechanics does not change very rapidly in our patients. So dealing with changing the lung compliance and then changing the pressure limit to guarantee the tidal volume, actually it's not very essential over a short period of time. When you have an intensivist inside your ICU, I think dual or adaptive control modes means a little benefit. Actually, that's regard the benefit of the dual control modes. So regarding the benefit, I think it's doubtful. If you have an intensivist bedside with or an RT bedside with the doctor, he will change the settings that suits the patient. Yet the most for my opinion, the most benefit we get from the PRVC or the AutoFlow is allowing the patient to control his own flow. So if the patient has a moderate effort, he is the ideal patient for PRVC. A patient who is passive, it doesn't matter, you give him volume control or pressure control or PRVC, and the patient with high effort does not fit with the AutoFlow or the PRVC. But the patient with a moderate effort, in my opinion, is the best patient that fits with the PRVC mode.
What about the disadvantage of this mode, Dr. Mohammed?
Disadvantage of this mode, first, we cannot we do not have a constant mean airway pressure over the period of time, although this is not a problem. There is a potential for hypoventilation, and if the patient have a high effort, the ventilator will be deceived and will decrease the pressure limits. So there are some potential problems with the PRVC or the dual control mode. Okay, and in the volume support mode, which is the spontaneous pattern of the spontaneous brother of the PRVC, giving an extra support is sometimes a problem with the volume support mode.
Yeah,
to achieve a tidal volume of 8 or 6 ml per kg per predicted body weight using the volume support mode.
Another question by Dr. Muhammad Ahmed asking about another two modes, which are adaptive supportive ventilation or ASV and the auto mode of Mackay ventilators. Are they equal to dual control modes?
That's a very good question. Actually, auto mode is the only, in the Mackay, is the only dual control mode. All the dual control modes we have just said are rather classified as adaptive modes, adaptive control modes. PRVC, AutoFlow, volume support is misnomered as dual control mode. It's not a dual control mode. They are adaptive modes. But the auto mode in the Mackay is the only dual control mode, actually. ASV is not a dual control, neither adaptive. It follows another optimal, it's called an optimal target scheme. It's only found in Hamilton. It's the basic mode in Hamilton now. And it's the platform of the IntelliVent mode in Hamilton. And auto mode shifts from a volume mode, from a control mode to a spontaneous mode in the Mackay or the getting ventilator, is one of the few actual dual control operating system modes. But it's not the mode we are talking about today, because we changed the name from dual control, which is a misnomer but commonly used, to an adaptive control mode. So ASV is not an adaptive control mode.
A question by Dr. Muhammad Osman asking about the alarm and what is its important in PRVC mode.
Very essential. PRVC, it sets a pressure limit to achieve the tidal volume. Let's say it starts with a pressure of 20 to achieve volume 500. 20 did not achieve the 500. It will rise to 23. It only gives the patient 450. It would rise to 26. It only gives the patient 480. How much will it rise? It will rise till it reaches the alarm, the pressure alarm. When you reach the pressure alarm, you set in the ventilator and you cannot achieve the tidal volume. For safety issues, the ventilator will tell you tidal volume cannot be achieved. What do you think if the tidal volume 500 needs 50 centimeter water of pressure limit to be achieved? Is that safe? That's not safe. So setting the alarm is just a safety valve that the pressure limit will not exceed even if it cannot guarantee the tidal volume. يعني لو ما حققش tidal volume مش هيعدي الالارم ليميت اللي حضرتك ظبطه، سواء في الفوليوم سبورت او في البي ار في سي، او بيعديه ب 5 سم بس في الاوتو فلو.
Another question asking about difference between dual modes and intelligent modes.
So intelligent mode is another one of the other 7 operating or target schemes that follows the another pattern of ventilation. As an example, IntelliVent. In IntelliVent, it does not adapt itself to the lung mechanics. You just set the saturation you need and the CO2 you need and connect a capnography and pulse oximeter to the ventilator. And the ventilator, by artificial intelligence calculator inside it, calculates which PEEP and which FiO2 is good to give the saturation 90, and which rate and which tidal volume will give the CO2 45 to 50. So this is another pattern of dealing between interaction between the ventilator and the patient. It's not adaptive. It's another operating targeting scheme.
Another question about another mode, which is MMV mode or mandatory minute ventilation mode. I think we have a lot of advanced modes which with different concepts. We cannot discuss them all in one lecture, but we have an idea. Yes. And we may be in the next webinar, we will discuss one by one, inshallah. So what is your opinion, Dr. Muhammad Amin, about MMV mode?
Actually, MMV mode is not a new mode. It's a mode invented in the 1980s, 1988, if I remember. It's one of the earliest closed loop modes. All of these modes we are talking about are called closed loop modes. So MMV is one of the oldest closed loop modes. I think for me, I do prefer the ASV, which have a similar concept a little bit to the MMV over the MMV. ASV use the Otis equation or Otis law to choose the best rate and the best tidal volume to achieve the minute volume for the patient. MMV also achieve a minimal minute volume or a guarantee a minute volume per minute, yet it uses another algorithm. I do prefer the ASV over the MMV, and we will talk about both in the respiratory care series later on, inshallah.
The last question by Dr. Ahmed Fayed was asking about if we have a misnomer of adaptive modes as they are dual control.
Yes.
How is the real dual control mode defined? How can we define dual control mode?
Dual control modes that shift from pressure control to volume control in the same breath. That's the operating system of a dual control mode. But adaptive modes that adapts to its pressure limit according to the change of resistance or compliance of the patient is a different pattern. They were called dual control modes. So this is an old misnomer we cannot change over time. Like the PEEP. PEEP is not PEEP. PEEP is CPAP, but it's called PEEP. We have accepted this all over the time. So dual control modes, actually, there are very few true dual control modes. None of them is the PRVC, nor the AutoFlow, nor the volume support. But this is a common misnomer, so we will be using them all through.
I have one question, Dr. Amin. How can we use this dual modes or the adaptive modes in patients with air leak due to like bronchopleural fistula? In these patients, the volume, inspiratory volume is different from the expiratory volume. And I know that these modes are dependent on the feedback of the expiratory tidal volume.
Well, actually, that's a valid, good question. I don't have a specific answer for it. I'm sorry. Yet, I think from the concept point of view, it's valid to use it in minimal air leak and bronchopleural fistula. But I don't have a specific answer for this. I don't have an experience of using them with air leaks. I will check the literature and tell you the answer in the next webinar.
Many thanks, my Prof. Mohammed Amin, for this nice lecture and these questions. Some of the candidate asked about the link for YouTube channel. Yes, the lecture will be recorded and uploaded to our channel and will be sent for you in the chat now. The link for the YouTube channel.